This is problem number 3 from section 7.3. It says solve the equation for solutions over the interval 0 to 2 pi. Again, 0 to 2 pi just means one revolution, so we're just going to check the solutions in one revolution so we don't get infinite solutions. We just get those solutions inside 360 degrees, no coterminal angles. It says tangent squared theta equals -5 plus 4 secant theta. Now this problem can be difficult if you don't have some things memorized. One of those things that you'll need to have memorized is some of these Pythagorean identities. Now we have secant theta here, so you should be thinking whenever you start this problem, can I make secant theta into tangent squared theta or into a tangent? Or can I make tangent into secant? Well, if we look at these reciprocal identities, secant is 1 over cosine. Obviously tangent is not going to be, is not cosine. You might think, okay, well what if I make secant 1 over cosine and I make tangent sine over cosine? You're still in the same problem, or you're still in the same issue. By the way, that would be sine squared over cosine squared. But you still have the same issue because you have two different functions of the same equation. Two different trig functions. But if you look at the Pythagorean identities, you can see that tangent squared is tangent squared plus 1 is equal to secant squared, right? Which would be a secant, which is good. So if I just subtract the 1 over, I get tangent squared equals secant squared minus 1, so I can replace tangent squared with secant squared minus 1. And that's how we want to start this problem. So I'm going to write this now as secant squared theta minus 1 equals -5 plus 4 secant theta. And just like any other problem, we're going to basically solve for the roots. We're going to set this thing equal to 0. So we're going to add, let's go ahead and add 1 to this side. Well, let's move the 5 this way. How about that? We'll move the 5 this way and we'll move the 4 secant theta as well. So let's add 5 to each side and we get secant squared theta plus 4 equals 4 secant theta. Subtract this over, we get secant squared theta minus 4 secant theta plus 4 equals 0. So you can see here, this is very similar to a quadratic. All right, I'm going to take these Pythagorean identities off here. But it's very similar to a quadratic that would look like this: x squared minus 4x plus 4. So they actually show you a algebraic manipulation that you can use here. If you say x equals secant theta, you can replace the secant thetas with x and basically write this function like so that you can do the algebra easily and then just replace the secants back in there. Let's try it out. We know we can factor this to x and x. Plus 4, it's got what? 4 and 1 and 2 and 2. Well, if I make them both negative, that's probably the right route that I want to take, because -2 times -2 is 4. -2 times x is -2x. -2 times x is -2x, which gives you -4x. Okay, so I factored this correctly. So because I did the factoring here, what I can do now is I can replace that with secant theta. So I can go ahead and throw secant theta back in for the x values, and I can say that this is secant theta minus 2, secant theta minus 2 equal 0. So that means secant theta, and I really only have to do one of these, minus 2 equals 0, or secant theta minus 2 equals 0 as well. We don't have to write it twice though. Add the 2 over, secant theta equals 2. What we can do now is we can replace secant theta with, if we use our reciprocal functions, right? Because I don't know when secant theta is 2, but I definitely know some sines and when sine and cosine are different numbers. So why don't we replace secant theta with 1 over cosine, right? Because they're reciprocals. So I can say 1 over cosine theta equals 2. Multiply by cosine across, and I get 1 equals 2 cosine theta. Divide by 2, and I get 1/2 equals cosine theta. Okay, now we're somewhere where we can work. When is cosine theta a half? Well, we can pull the unit circle on here, and we know cosine theta is a half at 60 degrees, right? 1/2 here, 60 degrees. And then we know cosine's only positive in quadrants 1 and 4, so I just need to look down here and see that, 60 degrees and 300 degrees are my two solutions there. So I can say theta equals 60 degrees, 300 degrees. If they want it in degrees, if they want it in radians, I'd say theta equals pi over 3 and 5 pi over 3. Right? So it's one of these two. They tell me it's in radians for this problem, so I'm going to circle this one as my solution. Hopefully this helps.